So what you use is so-called TF-IDF. That's called expertise, the real understand of the business. TF is stand for term frequency. IDF is the inverse document frequency. Basically, they characterize the article by the weird word that author particularly like to use. Nowhere else you use it frequently. And those words are going to characterize like Shakespeare. You know, he has some words people never used it, and to characterize that article. So how do you calculate it? Look at those words. Is you count, as told you, statistical way, but not just count the number. The first count your document. The essay, just try to send your essay to this temp in to try to see if you are cheating. Look at the distance from another thousands of essay there to see if really similar. How they do it? They look at the TF is the term frequency. The term frequency like this. Everything has a frequency, like they in Chile and those words whole and Chilean, Argentina, and all have a frequency, the count. That's the side of the count. How many times you use how many words, side of that words. The inverse document frequency is use the logarithm n. That's how many documents you have in your corpora in the training set. Divided by the DF, which is the number of documents that use that term. That means if every article use the same article, like they use that word doesn't count. Because if everybody use the N over DF is 1, right? Logarithm 1 is 0. Do you see? That word does not get any weight. That's not a count. So what a count is, use this term frequency used, multiply the frequency at the inverse frequency, means that I give most weight to those rare used word in the corpora, in the other one. And if, let's put another way, if only 1% of the article used that word, and then this n is 100, logarithm of 100, they give you a bigger weight, right? Right? Okay, look at those words. This word appeared not too frequently, the rank number 7, but because, they, I don't know, penetrate, do you know this word? It's a location or something. But because nowhere else other people use that, in that count, the number 1 characterize this article, because this is a news maybe from politics in South Africa, South American, like another word, Spanish. And that word all the way down to here, very slow, but because not frequently in other place, ranked the number 2, but because I add this weight. And then so on and so forth. See, no, those words, if when you don't read the article, you pretty much know what they're talking about, right? Did you see? Genocide, political military dictator, and you probably know it's a news story, something happened in the politics of South American, some dictator, some murder or something. And those words are going to select it. Now, think about the art now. What is an art? And you write some newspaper, and you happen that the frequency is like this order with this kind of weight, very similar. That's almost unlikely, right? If you copied somebody's article, you can change the order, change everything, but the words is still there. You don't keep changing the words. Those keywords is there, the distance is sure that they're going to identify, and maybe if they're detected, a human being can read it. They say, okay, that's the same thing, you copied. And that's the easy thing. Can you see? Those words, you can very unlikely you're going to have the same frequency and use it the same way, because you're going to take away all those common words. Well, the point I want to put this is that, okay, it's very easy to write the nearest neighborhood, And the distance is really easy, but how do you normalize? How do you put the weight? Make the whole difference. If you don't put this weight, you pick those words, you won't succeed at all. Because every article probably end will use the day and of the same way, unless you're written by the Chinese. We don't use those very frequently. In our grammar, you know, probably you're going to see that's written by the Chinese. I always struggle with that, they and the A. Okay, but those things does not tell much. And what tell much is those weird words nowhere else used frequently, and you use the high frequency, maybe the same frequency as the other article, they really tell a lot. Yes?
How to protect someone who maybe copy from several documents from?
Well, that is a challenge, but still have a way. They chunk it in small pieces. They don't have to compare article to article. They can usually normalize the size of paragraphs, 100 words. In each 100 words, what kind of thing, they can do small chunks. And then if you copy the whole chunk, and they are also have other way to look at your consistency. Now there's a rising star, and if your star come with an inconsistency, first you get this kind of red flag. If your star is not consistent. For example, if you at the firm, you use those words even with the wrong frequency in each time, you probably will be identified you are not written by yourself. The coherence is not an indicator. And if you copy paste by little, there's a lot of ways they can identify that. Turnitin is a very successful tool to look at the people cheat. So essay is a filter. You write well, fine. You write middle, okay, it's okay. But if you plagiarize from somewhere, you got trouble. That's what happened. A lot of time in graduate school, you write an essay and you think you can get away. Because those things is cheap. You just send it to them, they're going to figure it out. Because they can shoot damage. And they can look at those frequencies. It's nothing. It's a vector. And this vector is saved. It's called the WordNet. WordNet saved all the corpora with all the frequency. And all you need is to turn the URL paper in and look at the frequency. And that's it. They're not going to really save the whole article. They save the frequency. Any other questions? So that's a very nice thing for research. For other research, even not necessarily the data mining. This is the old way, but we are a lot of times, especially natural language processing, it's always the first thing to start because it's cheap and easy to implement. And then we have other way to do it. The two-way naive Bayesian, this method works very, very efficient. Data mining is an interesting field. That's not always by to the complicated model. It's always by to the insight of the problem. The insight of the problem is just like those, the weight. That's why you have to do a lot of experiments to basically just how you think out some kind of attribute and make this attribute to distinguish out and to classify things. So not all attributes share the same value. We're going to talk this maybe in the end. When the undergraduate start talking about project, I'm going to talk about primary component analysis, PCA, or single value decomposition. That's always one of those things you have to use in science. So what is the important factors?